Okay, so again, thank you all for coming tonight and happy Mad Day, Manatee Appreciation Day. So let's just give a little bit of background about us. Just give you a brief overview, sorry, of what we're going to be talking about, a little background about what we do, a little bit of background of Manatee 101, and then we're going to talk about specific methods, research methods that I've used, although there's certainly more than just what I'm going to be talking about tonight. So there's acoustic research using their vocalizations, drones. Cora is going to be talking about photo ID and citizen science. You guys are really, really important to help us gather information on manatees as well. It's not just me doing all the work. So about us, we're a nonprofit established in 1981 by Jimmy Buffett and the former Governor Bob Graham. Our mission is to protect manatees and their aquatic habitat for future generations. We focus on education, outreach, legal advocacy, research, assistance with rescue rehabilitation, and release of manatees. So manatees, contrary to what you might have heard in the news not too long ago, have been on this planet for approximately 50 million years. They are native species and they've been here a lot longer than we have. And even on the coast of Florida, back around 10,000 to 12,000 years ago, and even beyond that. So manatees are air-breathing mammals. They can get relatively large, but they face a lot of, and there's multiple species of manatees. Otherwise, the common scientific name is known as Sirenian. This is a little bit older map, but we have the West Indian manatee, now commonly known as the American manatee, which comprise of the Florida manatee and the Antillean manatee, which is now known as the Greater Caribbean manatee. We have the Amazonian manatee, the African manatee, and my favorite, which I don't get to talk about much, is the dugong, but that's over in the Indo-Pacific. And manatees face a lot of threats in their habitat. So they face loss of habitat. You might have heard about the unusual mortality event on the east coast of Florida, which ironically was just closed today. Red tide, boats, entanglement, loss of warm water habitat, climate change, and harassment. So to combat some of these threats to manatees, researchers have to use multiple tools or research methods to find out some basic questions about manatees in general. For example, all the Sirenian species I just showed you, they use vocalizations to communicate. So this is a good indicator that vocal activity may be something that may be used to detect manatee presence, right? Citizens, right? Citizen science. It's so important these days. There's just one of me, but there's a lot more of you, right? You can help us answer some of these questions, either be biological based or research based, that can help us answer these questions and help protect manatees in their habitat. So what can vocalizations tell us about manatees? So manatees in Florida aren't quite the same everywhere else. When you go to look and find a manatee, particularly during winter months, manatees aggregate at warm water outflows. Even though they look big and chunky, they don't tolerate cold waters very well. So they tend to aggregate, and sometimes in rather large numbers, which you saw in that very first slide, in these warm water outfalls. What about those other locations in the greater Caribbean area? They're tropical year round. So they don't need to aggregate in these large numbers like Florida manatees do. So what can vocalizations tell us about manatees? Are manatees present? Are they actually using a habitat? Is it adult or is it a calf? Which might be really important when you want to know what your population is doing and how many animals are potentially in your population, what it consists of. Do they use a habitat? And what about captive environments, right? So manatees sometimes need to get rescued. They go into these captive environments. What can their vocalizations tell us about being in a captive environment? So just to give you a brief overview, this is some of the equipment that I use. It's a hydrophone or an underwater microphone that you use to basically listen to the sounds of manatees. We should know what manatee sounds look like, right? So this is some of the work that I did where we categorize the vocalizations they produce into 5 broadly defined call types. You have the squeak. This is the most common type that manatees produce amongst all species. The hill-shaped high squeak, which I'm going to talk about in just a moment. The squeal, another very common call type. A squeak squeal and a chirp. I'm going to play some sounds for you now so you guys know what manatees sound like when they vocalize. So manatees vocalize under all different behavioral contexts. And when they're playing, they're really, really vocal. When they're stressed, when they're resting, and when they're feeding. But how do we use these sounds to determine where manatees are, what habitats might be important to them? So can vocalizations tell you who's present? Are they there or are they not? So for this, we wanted to know about age, right? So how do you know about the age of an animal? So what we did for this is we recorded calves while they were in captive environments in Florida and in the greater Caribbean. And what I'm showing you are individual spectrograms or a graphic representation of sound of 6 individuals. So what I'm showing you here, this right here is one individual. The number here at the top is the length of that individual, right? So we recorded 6 individuals, and these are the sounds that they produced. They produced this hill shape high squeak call. And you notice as they get older, that hill shape tends to flatten out and become a more adult-like squeak call. Same thing for the Antillean or Greater Caribbean manatee. These, again, are 6 individuals recorded from captive environments. The lengths of these animals are in centimeters at the top here, and there's this individual, their individual voice, right? So again, that hill shape that starts to flatten out as they get older, become the more adult type squeak call. So what that tells us, and we can look at this again, so as the animal gets larger, you get this hill shape that turns into a flattened shape across both species. Why is this important and why do we care? Again, like I said, these animals, particularly Mexico, the Dominican Republic, Africa, and even Amazonian manatees make this hill-shaped call structure. So how do I know whether or not I have an adult or a calf? So you put a hydrophone in the water in a place where you think manatees might show up, and you can tell, one, whether or not you have an adult and a calf. And because they have individuality in their voices, so like my voice is going to be different from your voice, it sounds a little bit different. They also have individuality in their vocalization. So potentially we can use these sounds to determine approximately how many animals are in the habitat just by looking at the different pitches and the different frequencies at the voices that are in that habitat. So something we're still working on currently with some of our partners to use manatee vocalizations as an estimate of the number of animals in a habitat. Can vocalizations be used to determine use of habitat? So how did we do this? So we did this at a location in Belize in St. George's Cay. We used 2 microhabitats, which means these habitats are in very close proximity to one another. So you have site A here and site B here. They're really close to one another, but they're just a little bit different in their characteristics. They're both resting holes. One, as you can see, is closer to land and one is more offshore. So we looked at the trends and how they use the specific habitat. And what you can see is site A was closer to shore, was more commonly used at night. And site B had fewer vocalizations, but was more commonly used during the day. So this is telling us different habitats may be important at different times of day. So think about it. Site A, you get a lot of boat activity. It was really close to a marina. So more than likely, they might use that very minimally during the day. And they're going to use this other location more offshore, site A here, at night when there's not as much boating activity going on. It's a possible explanation for that. Or this site B, another explanation was it had a lot of forage out there. So maybe at nighttime, they kind of like, they like to forage more so at, actually, this one's during the day. I apologize. They're using this more at night and this is more offshore. So probably an explanation, the boating is what we think. African manatees, right? So we found that their vocalizations were more frequent at night. And this is actually very similar across species from what you saw in the last slide too. They vocalize more and they're more commonly move during nighttime hours. So in Africa, this may be due to poaching, right? Because there's still poached in some of these areas. And even in Florida, manatees will sometimes go out and forage at night and rest during the daytime hours. So it's very common to see manatee vocalizations and vocal activity during nighttime hours. What about captive environments? So sometimes manatees will go into captive environments. We will sometimes get rescue orphan calves. and they go into captivity and they can be there for up to 2 years until they reach a certain weight. And so you wonder when you're with these animals in captivity and you're actively throwing food to them and feeding them, does that influence their behavior? So you don't want animals in a captive environment to become dependent on humans. So they try to minimize as much interaction with these animals as possible so they don't rely on humans or go up to humans for food after they're released. However, we wanted to know, so animals in captive environments, they can kind of know that when a human's coming there to give them food, does their vocal behavior change in anticipation of getting a food source? So we did this study again in Belize. This was at Wild Tracks, and there's an including a lagoon enclosure with two animals called Teak and Nugget. So two captive individuals. So we recorded their vocalizations before they were going to be fed, during the time they were being fed, and after. And we wanted to know were there differences in their vocalizations. And the short answer is yes. So before they were being fed, which is the blue right here, you can see that's a lot of, this is the number of calls. There's a lot of vocalizations there. So they were able to see when the trainer was coming or the person who was feeding them was coming, and they increased their vocalization rate. During feeding, they decrease it substantially. So manatees, they're kind of like humans. They can't chew and swallow at the same time. So it would make sense that their vocalizations would decrease. And then after they were done feeding, their vocalizations increased again, but not slightly to the extent that it did before they were getting fed. So this is telling us that manatees know when they're going to be fed, and they anticipate these behaviors. They anticipate that someone's coming to feed them, and they alter their vocal behavior in response to that. Something we might not want to see, but something that does happen sometimes in these captive environments. What about construction of new pools? So Zoo Tampa is currently expanding their capacity to be able to take on more animals. So, during the UME, part of the issue was, and part of the ongoing issues, is sometimes we want to rescue more manatees, but we just don't have the capacity or area to be able to put in all these animals. So they're doing a wonderful thing, and they're constructing some new pools. But along with that comes a lot of noise. Construction is noisy in general. So they reached out to us and we're like, can you look at the noise levels and see how manatees are responding while all this noise is going on during construction? So what I'm showing you, the spectrogram right here, is some of the noise that can actually be heard underwater. So sound doesn't transmit very well from air into water. If you're in a pool and someone's talking above you, if you're deep down in the water, probably not going to hear it really well. But when it's really loud, like construction, it does penetrate deeper into the water column. So this is an ongoing project right now. Their construction is going to be happening for the next year or so, at least at a minimum. So we'll be looking at how loud is the sound that they're being exposed to, and what are the behaviors that they're doing? Are they stop feeding? Or are they doing more behaviors where they're sinking to the bottom? What behaviors are they engaged in? What vocal behavior are they engaged in or not engaging in while this construction is going on? And from what we know from previous studies that were done, sometimes when it's a really noisy environment, manatees don't vocalize when it's really noisy. So this will be something interesting to see what we get when this research is done. Drone research. So drone can be used as a tool for gaining information about Florida manatees. How do we use this? One, we use it to find animals in need of rescue, use it to identify tagged individuals, photo identification, how many animals there are, body morphometrics, and use of habitat. So if you've ever been in a boat and looked out, you've probably, so it's kind of really difficult, at least it was for me, to look out from land and try to find a manatee. But the drone gives you a whole new perspective. And this image that we're showing you right here is actually from Blue Springs. And we just took this literally a couple of months ago, where we're trying to look at body condition of these animals. But this gives you a general idea of how many animals that you can see. So you might think this would be a lot easier to count animals like this when you also more lucky that the water is clear and you can see what's going on. But it gives you a better view and a different view, and it gives us a lot of things to see that we weren't able to see before. So for instance, this was a rescue that I helped with, this was flapjack, right? So I went to an area in St. Pete and I flew the drone and I canvassed and I transected this area. And this guy was very stealth. I didn't see him when I was flying, but I always take video when I'm flying. So I was able to look back and see right in the corner that this little guy over here decided that he was going to come up to the surface when I didn't see him in my viewfinder. Because sometimes the viewfinder that you have, it can be rather small. Sometimes it's a cell phone. I tend to use an iPad, so I get a much larger view. But he came right out of the corner, and that's when I was able to spot. And because of our continuous efforts and some citizens who actually kept reporting that the animal was still there and our visuals, this animal was rescued. We also used it, and I hope I can play this. So this was up during the hurricanes. After the hurricanes, the water level rises a lot. So manatees sometimes will go into areas that they weren't able to get into before. So they were trying to rescue this animal in Hernando County, and it's a series of canals. I'm hoping I can play this. Oh, yay, it's playing. So this is me flying the drone. You see, Florida Fish and Wildlife is down there in their canoes, and they're looking for this animal who just evaded capture. They've been looking for this animal for about a good 3-4 hours. So I'm following with the drone, trying to follow this animal, and they're asking me, do you see this animal? So this animal had escaped the nets down at the end of the canal, and we're going to come up to, and this animal was pretty stealth too. If you look up here in your upper right, he's already rounded the corner and went up there, and they're still looking for him down at the end of the canal. So I was able to tell them that, look, this animal's already escaped, and I could tell him where they went, exactly where they could go, because you could either go this way or you could go this way, and they would have spent a lot more, significant more time looking for this animal. But because I was up there flying, I could tell them exactly where the animal was, exactly where he was located, and they were able to rescue that animal and get it back out into the wild pretty efficiently. So like we said earlier today, which is a good thing, that the manatee mortality event along the east coast of Florida is now closed, which is a good thing. We're very grateful to hear that. But during this time of this manatee mortality event, we were wondering, what can drones help us with to look at body condition, number of animals, and to be able to check on these animals, particularly on the east coast of Florida, right? So one of the things you can use drones for is photo identification. Now, I'll let Cora go into this into a lot more detail, but they have distinct scar patterns, right? And you can use the zoom image on a drone. So even though I'm maybe 200 feet in the air, they now have, I think, up to like 25x zoom, some crazy amount, where you can zoom in and look at these individuals so close up. In the beginning, when drones first came out, they didn't have those capabilities, usually 1x or 2x, but now they have a really great capacity to zoom in really close to these animals. And sometimes it's really hard to look at scar patterns from the air. They really have to be definitive for you to be able to see them, because there's really small nuances between different scar patterns in animals. So the drone will allow us to zoom in really, really close at a safe distance where we're not interrupting or disturbing their normal behavior, and be able to photo identify manatees. We can also look at those tagged individuals. So orphans get tagged, right? Get tagged so they can follow them GPS just to make sure when they're released, just to make sure they're being manatees. During the UME, they were also tagging manatees to see where are they going to find food. Since a lot of the seagrass was gone in the Indian River Lagoon, about 80% of the seagrass was missing, they were tagging individuals to where are they going to find food, right? So because of this, we were able to look in the drone through the drone imagery and be able to see some of the images, some of the manatees that they had tagged. And we reported that back to our partners, namely Florida Fish and Wildlife and the United States Geological Survey, because they were curious where their animals were. Were they coming to the warm water refuge? Where are they going? But we could see them at Canaveral Energy Center. And this is just one screenshot. And there's about 300 animals in the image. In the first image I showed, there's about 350, and we counted approximately about 1,200 individuals, which is what I'm showing you here. So sometimes a lot of this is done through an airplane, and those can be quite costly to do aerial surveys, and they are really good at covering large areas. So if you want to cover a much smaller area, say this Cape Canaveral Energy Center site, we can actually count the number of manatees. And like I said, there's approximately 1,100 on this day alone. So it really gives you a different vantage point, a more cost-effective way to be able to count the number of animals in a specific location. So body morphometrics, this is the thing that I was showing you in the image I was showing you in the very beginning about Blue Springs, looking at body condition of animals. So they do this with whales, they do this with sea lions, they do this with other marine mammal species. And you can tell sometimes in these animals that they get thinner and thinner over time. You can actually measure this from an image. It's called body morphometrics. So we were thinking, why can't we do this for manatees? Why can't we use these images and measure the body condition of manatees? Wouldn't that be a great way to do it? So how it's done right now is Florida Fish and Wildlife and United States Geological Survey go out, they capture individual animals, and they do a health assessment. And that's really important too. And they want to get an overall estimate of how healthy are these animals. But they only are able to capture sometimes 15 to 20 individuals. Wouldn't it be great if we could look at those 1,000 individuals and be able to give you an idea of how the health of the subpopulation is, not just from 20 individuals, but from 1,000 individuals? And that's where this idea was born. So what we want to do is look at the drone and look at the body condition of animals. So number one, maybe a not so healthy animal, we give them a score between 1 and 5. So this animal kind of looks a little bit thin, to up number 5 where they're big and plump. So how do we do this? So we use a software called Morphometrics where we kind of circle in on an animal. And we use this software to take measurements along the body of the animal. So we focused on a couple different locations. We focused on the neck. We focused on the belly, the umbilical girth. We also all focused on the maximum width and right around the tail or peduncle. So why those areas? So when manatees start to lose weight, they sometimes will get a peanut-shaped head, and we've noticed that they lose it around the tail. So we're still working on this, and there's some caveats here. So manatees don't flatten this way when they lose weight. They flatten this way where their bellies get more thin. But we're not giving up on this yet, and this is why we're using multiple indices to see if we can start picking things out about from the head and the tail to see if we can start get a general idea of maybe health, and are they different? We also want to look at different locations to see if body condition differs between somewhere like Blue Springs where they have really good forage and somewhere on the East Coast. Do they look kind of different? So they actually are. So from some of our preliminary data, we compared actual measurements from animals in Crystal River and animals in on the East Coast of Florida and found they definitely differed in body condition. But this was only 1 year of data. So is that how they normally are, or is it the UME something we can account for and say that there's differences? So we need to look at this over time. So having the first year of data in Blue Springs, now we can look at next year if we can see if body condition changes from year to year. And if it's changing, maybe in a negative way, that might be an indicator that we're losing some of the seagrass in the habitat. We also want to fly at CCEC again. So we have the data from the year during the unusual mortality event. So maybe in another year or so, we can go back and see if their body conditions change from that year to the next year, to a couple of years after the UME is over. You can also use drones to do seagrass surveys. Now, again, these are also done by airplanes. However, drones can cover a really small key area to figure out if the specific area that you want to focus on is increasing or decreasing in body size. So how does this work? So how this works is the drone takes multiple images. And for this small data set, like maybe 1,400 square feet, it took over 800 images. And it basically pastes all these images together to form an orthomosaic. So all these pictures are combined together to produce one image. So we did this at a location in Sarasota. And basically what we could do is we could look at the percent coverage and how it changed over the course of a year, because seagrass will grow and sometimes it'll die off during the year. So we were able to look at different flights over different times of year to see how the seagrass changes over time and just over the course of the year. They do seagrass surveys sometimes every 2 years, and in some locations every 4 years. So in the interim, when we have stuff like hurricanes that may impact seagrasses, we could potentially go out with the drones and look at that change in seagrass for a very short period of time, as opposed to these very long periods that we wait to look at seagrass coverage. With that, I'm going to turn it over to Cora.
So now to my part of the presentation, I will be covering some of the photo ID research and pretty specifically at Blue Spring State Park, where I do a lot of my work alongside our main researcher, Wayne Hartley. So what is it that we do when I talk about photo ID research? Okay, that doesn't seem to work. Okay, here we go. So primarily we do photo ID and genealogy research, and that goes back to the early 1970s. We count the individual manatees, and we also identify the individuals. Manatees, as Beth mentioned earlier, are identified by their scars, and as you can see here in this picture, that manatee in the foreground over there, you can see that white outline on his back. That's a scar from a boat strike. So this is how we recognize them, is by their individual scars. For that, we use scar sheets, which I will show you in one of the upcoming slides, as well as photographs. The data is then submitted to the statewide Manatee Individual Photo Identification Database. So while we do this research at Blue Spring, there is many other organizations and other researchers who do very similar research at other sites. So then all of this information is entered into the main database, and so we can actually compare individuals between different sites. In addition to that, we also record the number of boat strikes that happen during the winter season. We record number of calves and the number of manatees who, quote unquote, stay the season, meaning we see them before January 1st and after January 1st. So the research that we do at Blue Spring is really counting the manatees in this winter aggregation site. For those of you not familiar with Blue Springs, it's one of the main winter aggregation sites for Florida manatees, and that's where they come when the water gets below 68 degrees, and they're congregating there in the hundreds. We also assist with rescue and release of manatees, as well as with the recovery and identification of deceased manatees. So now, how do we actually count manatees? That is one of the questions I do get the most. So you can see here on this drawing, the spring run is divided into 19 different transects. So over here by that blue line, this is where the St. Johns River would meet the spring run. So we start right here at the spring run, and then we paddle in our research canoe all the way up to the spring head, and we count the manatees per transect. So we count them by hand. We don't have AI, we don't have some sort of app, we don't have a system where the manatee swims through and gets counted. We do all of that by hand in each transect, and then we add them up at the end. The park rangers also count the manatees from the boardwalk, and sometimes our counts differ just based on conditions. So it might be very sunny or very windy, where it might be hard to see them from the boardwalk, or it might be harder to see them from the canoe. There's also always some observer bias, so sometimes we don't come up with the exact same counts. Manatees react to temperatures very fast. So we have days where we have, for example, on this past Saturday, it was pretty cold out in the morning, cold for Florida, and we had over 200 manatees in the spring run. That dropped to about 180 on Sunday, down to 51 yesterday, and down to 4 today. So that was a pretty quick drop, but that's how you can see that the manatees react to those temperatures really quick. And what kind of other data do we collect when we do our photo ID research at Blue Spring? So we do record the air temperatures, both the high and the lows, the number of manatees, and the water temperature. And when you look at this graph, which is just an example of the 2022-23 winter season, you can really see how low air temperature, which is that graph here in the light green, correlates to very high manatee counts, which is this graph here in that turquoise color. So as you can see, the lower the air temperature and the water temperature gets, the higher the manatee count is going to be. So like I said before, we do genealogy research, and this is just a quick example. I do not expect anyone to memorize this, but it's just kind of a visual of what it looks like that we do. We go with the females because we keep track of them having their calves. The males are not involved in the genealogy, unfortunately. So for example, this is a very long genealogy going all the way back to a very original manatee from the early 1970s. His name was Emma. And then going all the way through Emma's daughter, granddaughter, great granddaughter, and so on and so forth, all the way down to Ian's calf, which is the last one right now in their genealogy. So we record the birth, and then we can record who is who, and hopefully we get, 7, 8, or 9th generations. So who is who at Blue Spring? We have 3 categories of manatees, basically. The first one will be the known Blue Spring manatees. They have a number which starts with BS for Blue Spring. So for example, here we have Blue Spring 107. This is Phyllis. As you can see, she has some pretty identifying scars, and we recognize her right away. She's a known Blue Spring manatee. We also have manatees every winter season that come in, and they have really significant scars, but we have never seen them at Blue Spring before. So we will give them an unknown number, or a U, followed by the number for the season. So for example, this one over here was U1219. You can see very significant scarring, but we had never seen this manatee before. At the end of the season, when we're really sure this is a new manatee and this is not just someone who got a big new scar covering up all these older scars, and we also compare our sightings with other researchers, and we can make sure that this is a manatee we don't know, that manatee will get a Blue Spring number and a name at the end of the season. And then last but not least, we have the seasonals. Those are mostly juvenile manatees, and they have some sort of superficial scarring. Those could be little scratches, or maybe just like a very new, fresh scar that we don't know what that's going to look like going forward. So they get a very temporary S number for seasonal. We can keep track of them throughout the winter season, but we don't necessarily going to recognize them if they were to come back the following year. So here's just a very quick example of what our scar charts look like. And these are the ones we use at Blue Spring, but like I said, they're used in other parts of the state as well. So the manatees all get drawn on here, and we have to redraw them and rephotograph them every year because old scars may heal and change. New scars may cover up old scars. So there's always the need to constantly revisit those. We also get manatee visitors at Blue Spring from other areas, so there's definitely some overlap between other springs along the St. Johns River, as well as some manatees from the East Coast that will be visiting Blue Spring. So here's just a quick example of different visitors from other parts of Florida. So matching manatees is not always easy. Like I said, scars can heal and change. Manatees have this really wonderful ability to heal. And oftentimes what you think is going to look a certain way next year, it will actually heal a completely different way. New scars may cover older scars. Like I said, they may heal very differently than expected. So here's just one example. This was a manatee that we actually helped rescue a couple of years ago, and you can kind of see on her lower back there's this pretty significant white scar here, and the following season that scar was just a mere little gray dots, which you can barely even see. This was another manatee that got a pretty fresh hit. Here we really didn't know how that would heal at all, and it came back the following season, and it basically looked exactly like it looked the season before. So very unexpected that it would heal like that. And then we have one here, which is kind of the opposite. It had a pretty significant fresh strike there on the back. And the following year, you can basically just see these little white dots here, but you cannot really make out that this was the same animal. So very difficult sometimes. And then we do have manatees that have a fairly significant scar, but then they get a new scar over the summer. So they come back in the winter time. And we really have to kind of look beyond this big new scar here and look at that older one, and we're able to match that to a known manatee from the season before. So I just want to very briefly mention our webcams because they are a very important tool that we use for our research in addition to going out on the research canoe in the morning during the winter season. So the webcams are a great education and entertainment tool for the public. I hope a lot of you are probably familiar with them and you watch them on our website, but they also assist us with our research. And we operate them in collaboration with Explore.org and the Florida Park Service at 3 different sites in Florida, including Blue Spring. So what have we learned from the webcams that's important for our research? So first of all, they gather additional sightings for the photo ID. They're also able to monitor behaviors, especially those ones that are kind of hard to observe and document in person. What I think is the most important thing for me personally is that they collect observations on manatees of concern without actually having to get into the water with the manatee. This is extremely helpful because the cameras are stationary. The manatees don't even really realize they're there, although sometimes they come to check them out. But an injured manatee may just swim past the camera and we get these beautiful shots of body condition and of the injury without actually having to get in the water, approach the manatee, which would obviously cause more stress for them. So they're really great passive tool to do these kind of observations. So just to give you a couple of examples from over the years, for example, here we have Manatee Hanako. She does have some buoyancy issues. The behavior was very difficult to document in person, but our camera was able to show how she was really having trouble surfacing over quite an extended period of time. So a very good way to kind of document that. Here we have Manatee Matahari. She actually came in during the summer months, and as you can see, she is followed here by over 20 males. This was a mating herd happening in May of 2023. We were able to identify most of those males based on the scars that they have, which without the webcam, we would have not even known that this had occurred because we do not do surveys during the summer months. It's very, very rare to have 20 to 30 manatees coming in the summer months like that. And then we did know that she was in a mating herd, so she actually brought a healthy calf in June of 2024, which was also recorded on the webcam. Here we have Manatee Moira Rose. She was a code stress case, but she also went right by our underwater webcam and did us the favor to roll over, and we were able to document that she was also very pregnant, which influenced the decision on rescuing her and having to be extra careful during that rescue. And then last but not least, we have Manatee Ting Ting. It's a little bit difficult to see here in that picture, but if you can see, there is a really tiny little calf over here. She was an orphan calf, and our webcams were actually able to document her trying to latch on to these other females, trying to nurse, but she was constantly being pushed away and just like wasn't thriving. And this was a really great behavior that we were able to observe on the webcams over an extended period of time, which I mean about a week or two, which really gave us reason for concern, and we were able to pass that information on to our to FWC for rescue, and they were able to use that footage and use these photos to really solidify the need for rescue. So last but not least, and this is going to transition over into the next section that I will hand back over to Beth, but last but not least, I'm going to talk a little bit about our summer research at Blue Spring. So everything that I've talked about previously, we conduct during the manatee season, which runs typically from mid-November until about right now, about the end of March. Now, we also have some manatees that come in during the summer months. So in 2016, I started gathering summer sightings because more manatees started to frequent Blue Spring. These data were actually gathered from our above water webcam that is on for research purposes in the summertime, as well as in-person sightings. So it's not as accurate as what we would get during the winter months. These are really minimum counts, but it's pretty significant to see how these numbers have really climbed over the years. Possible reasons for manatees coming into the spring and the summer could be that it's a protected area. It is used as a calving ground by females. We've seen an increase in the manatee population in that area during the winter time. So there's going to be more in the summer as well. And some manatees are just curious. They like to check it out. So all of this led us to create the Manatee Blue Spring Manatee Observer Volunteer Program, which is a collaboration between Save the Manatee Club, Blue Spring State Park, Volusia County, and Clearwater Marine Aquarium Research Institute. So we have a large pool of volunteers that help us gather these sightings and at the same time be at the park, educate people about manatees, try to prevent harassment during the summer months. So none of this research could be done without the active help of all of our volunteers. There is no way I could be out there every single day in the summertime gathering these data. So it's extremely important for that. So, and with this, I'm going to hand it back over to Beth for the last section on citizen science.
So just one thing I wanted to add to what Cora was talking about, the webcams and the drone work. So like I said, manatees flatten ventrally. So that webcam is going to be really useful for us because we can get the full volume of the animal. And that's the next step that we're looking at. If we can't look them topside, maybe we can get an estimate using a model looking at their full body, and that will give us an indication of body condition. So more work on this to come. Citizen science. I can't tell you again and reiterate how important you are in this work and how much it really helps us for you to work with us and the work that you can bring to the table. So one of the things that we did a citizen science project in Portofino Park where they have a lot of tour boats come in. And we trained individuals such as yourself just to document the number of tour boats that were coming in and what they were doing. We also used trail cameras and did surveys so we could document when citizens weren't there, how frequently tour boats were coming in. But the citizen science aspect was so important because even though I could tell in a trail camera when a boat was coming in, I didn't know if it was coming in there to fish, or I didn't know if it was coming there to look at manatees. So the citizen science was really, really an important aspect of this project. And what did we find? Just from the citizen science aspect, we knew that it seems like, a lot of people and tour boats were coming in on the weekends. They were coming in almost every day. But also, like I said, tour boats were coming in there to fish. And this just gives you an idea of the number of observations that we saw, the observation time frames that was conducted by citizen science. And it actually agreed with what we saw at the trail cameras. They were still able to corroborate the days of the week and the times of the day, even though they weren't there as frequently. They could still see, and they supplemented the data that we got with the trail camera. And it was very similar and very important, showing you how valid the citizen science is, even when they're not there. We also did some citizen science in Fort Pierce. So the Henry D. King power plant went offline. Believe it was back in 1998. And so they had a Manatee Observation Education Center, right? And they started documenting manatees and the presence of manatees after the power plant shut down. And they had their volunteers do this, and they did this for 20 years following the shutdown of a power plant. That's almost unprecedented to have that much data on the occurrence of manatees. So what I'm showing you here is this graph looking over those 20 years of data that told you basically even after the power plant was shut down, manatees were still coming to this site. Not in the numbers that you saw when the power plant was in effect, like they had 30, 40 individuals, but animals were still coming to this site. And it was really steady over 20 years. So why? Why were they coming to the site? One was freshwater outflow. Manatees like fresh water and need to drink fresh water, but also because it was a passive thermal basin, meaning temperatures in this little area right in front of the observation center were slightly warmer than what it was in the lagoon. Not for long periods of time, maybe a day or two, but manatees were definitely drawn to this area for a source of warm water for a very short period of time. And it's used mostly in March and November, mostly as a stopover. So manatees like to go to they're like heat-seeking bullets, right? Heat-seeking missiles, so to speak. They like to go to the best quality thermal refuge. But on their way there, they'll stop over at this Fort Pierce power plant or the Manatee Observation Education Center to get warm water for a very short period of time. So how can you help us? You can report manatee sightings to our sighting form. Currently, I'm engaged with a group in Clearwater that is actually using the sightings that they're putting to our to our database to see if this area requires a manatee protection zone. Florida Fish and Wildlife keeps this data as well, but they mostly do surveys during winter months. But what happens and what do manatees use during summer months? That's where your sightings and your reports come in and come in so handy. So we know if some of these habitats and where manatees are found are really important, particularly during summer months. So how can you get involved and how can you help us? Again, so you can join the Save the Manatee Club email action alert team, right? These are things, particularly what's going on right now. We can tell you things that are important and you might care about. So microplastics, changes to critical habitat to manatees, changes to their status. Are they going to be staying threatened, or maybe they're going to stay threatened is what is being proposed right now. Things like that you can get involved and let us know about. So we can contact your policymakers about issues relating to manatees, some of these particular ones that we were talking about, also Florida Springs. You can adopt a manatee. You can order free materials. You can join our volunteer team. You can follow us on social media, and you can watch Manatees live on manateetv.org. You can also, if you see something in your neighborhood that's disturbing to you, or maybe an issue that you might think impact manatees, you can send an email to us. We do respond to you within 24 hours. And I can't tell you how many times people have sent me information that we got involved and were able to help manatees in your neck of the woods. Like I said, I'm based on the west coast of Florida in Bradenton. My colleague is on the west coast as well, but let us know what's going on in your neck of the woods. And if you have any concerns about manatees, wherever you are, even if it's anywhere in the world, because we also help manatees, like I said, around the globe. We currently have projects now in the Dominican Republic and Haiti using acoustics to look at these animals here and see their use of habitat. So anywhere you are in the world, and also in Africa, we're just starting a project there looking at manatee use of habitat in the Natem River. So anywhere you are in the world, we want to help with manatees. So anything you can provide to us, any information you give to us that we can help, we are more than happy to do so. And I want to thank you so much. There's been a lot of you here tonight, which is awesome. I'm so glad all of you turned out and stayed for to watch the whole presentation.